Okay, so here's an example of a nonlinear inequality. We have x plus 3 times x minus 3 is greater than 0. And we want to figure out what values of x will make this true. And we want to write it in interval notation. Okay? So what we're going to be doing here is we want to try and figure out where this is true. So what we're going to look at is where does equality hold with this equation. So if I replaced this inequality with an equality, where would this happen? Because this is kind of the boundary, like when this equals 0 is where it would kind of change from being positive or negative. And so if we can figure out where it could change, we can figure out where it would be true and not be true, if that makes sense. So we're going to replace our inequality with an equal sign and think about what values of x solve this equation, right? Now, hopefully, we've done this a lot. Hopefully, this is quite clear as to what the solutions are, but this is factored, right? And it's equal to 0, so I get that x would need to be, I could set this factor equal to 0, which would give me negative 3, or I could set this factor to 0, which would give me positive 3. Okay? And so either one of these works. These are the places where we actually equal 0. So those are the places where this function could kind of change from positive to negative. So these are kind of places to be aware of is where it could change, okay? So then what we do is we think of, well, we know negative 3 and positive 3 are places where this could change from being positive to negative. So I think about, those are the places where it could change. I just need to figure out what chunks of the number line actually have this thing being greater than 0. So what we do is we take a number in this chunk right here, so less than negative 3. You can pick any number you want. It doesn't really matter, just as long as it's less than negative 3. Let's say negative 4. That seems like a nice, beautiful number. We'll plug that into the equation and see if this inequality is true. Okay? So I'll replace x with negative 4 in the equation. Negative 4 plus 3 times negative 4 minus 3. Okay? When I do this, this is going to be negative 1. The other one is going to be negative 7. Negative 1 times negative 7 is positive 7. Okay? So it's positive. Is positive 7 bigger than 0? Yeah, it is, right? So the inequality is true over here. Okay? So it's true on this side of negative 3. And it would be true at every point over here, not just negative 4, because the only places it can change are at negative 3 and positive 3. So all of these points over here need to be kind of doing the same thing. Okay? So now we would do a very similar thing for this chunk of the number line between negative 3 and positive 3. Okay? So I would pick some number in between negative 3 and positive 3 to plug in and see if it works. So what's a good number between negative 3 and positive 3? We can maybe do 0. That should work just fine. If I plug in 0 into the equation, I'm going to have 0 plus 3 and 0 minus 3. Okay. So this is going to be positive 3 times negative 3, which will give me negative 9. -9 is not greater than 0. So that doesn't work. 0 makes the inequality untrue. So it's not true in this middle portion. Okay, does this make sense? Okay, so now we're going to do the very same thing, just out here, beyond 3. So I would look at a place beyond 3, maybe 4 seems like a nice place to plug in. We'll plug that into the equation. We'll write this over here. So we have 4 plus 3 and 4 minus 3. Well, 4 plus 3 is positive 7 times a 4 minus 3 is a positive 1. So those are both going to be positive numbers times each other will give me positive. So it does work over here. Okay. So we've been able to figure out exactly what x values will solve this inequality right here. And it's the ones to the left of -3 and also to the right of +3. So how we would write that in our interval notation would be, well, I'd go from -infinity up to -3, but not including -3 because this is a strictly greater than sign. We're not having it equal 0, okay? And then my other interval was from 3 to, here, maybe I'll write it up here. My other interval is from 3 to infinity, okay? So these are the two places where it will work. So I just throw a U between them, meaning it can be in either one of those places and work. And this would be our final answer here. Okay. So this is very similar to what we did before for linear inequalities. It's just a little more complicated now because there's multiple places where the inequality can change. And so we have to look at first, where is this inequality actually an equality? Okay, so we replace this with an equal sign, solve for x to figure out where could this change from being not true to true and vice versa. We take those points on the number line and those are kind of the places where it could change, okay? Then we plug in numbers into the inequality to check every region on the number line to see where it's true and not true. And we take the regions that are true in our final answer, okay? So hopefully this is starting to make some sense. We'll do